Elon Musk's latest post on X about Tesla's enormous Terafab facility has attracted attention because of its massive scale and the large number of Optimus robots expected to be involved. But the most interesting detail was not the factory itself. It was the appearance of the Robovan, the box-shaped autonomous vehicle that first captured attention during Tesla's We Robot event. Its unexpected appearance has raised an interesting question. Could Tesla be much closer to putting the Robovan into production than most people currently realize? Just a few days later, Tesla appeared to strengthen that possibility in a more concrete way. According to information shared by @slamming on X, Tesla was officially granted a U.S. design patent after initially submitting the application in October 2024, shortly after revealing the Robovan. The patent credits Tesla's chief designer, Franz von Holzhausen, along with Julian Belau, Ian Kettle, and Joseph Robinson. Unlike utility patents, which generally protect engineering technologies or autonomous driving systems, this particular filing protects something equally important: the visual design and identity of the Robovan. At first, protecting the exterior appearance of a concept vehicle may seem like a routine legal step. In reality, design patents are becoming increasingly important as products develop into recognizable brands themselves. The patent illustrations immediately show that Tesla is not simply attempting to create another electric shuttle. Most existing electric shuttles on the market, including vehicles such as the Ford e-Transit, Mercedes-Benz e-Sprinter, and numerous Chinese electric minibuses, still use proportions inherited from vehicles originally designed around combustion engines. They typically have front sections, conventional windshields, visible wheel arches, and layouts centered around the driver's position. The Robovan completely abandons those traditional assumptions. Rather than looking like a conventional commercial van, the patent presents something that can best be described as mobile architecture. The vehicle looks more like a futuristic lounge or autonomous transportation capsule than a traditional people mover. Instead of having separate body sections joined together, the roof, side panels, and lower body appear to blend into one continuous form. There is no obvious hood, no extended nose, and almost no visual interruption across the exterior. The result is a smooth, seamless shape that feels more like modern architecture than a conventional automobile. And this design is not simply about appearance. It reflects a completely different engineering priority. Elon Musk has explained that the vehicle could eventually carry up to 20 people, while also being configured to transport goods. That means it could be used for moving cargo throughout cities, or transporting as many as 20 passengers at a time. During Tesla's We Robot event, Musk said the Robovan could eventually accommodate up to 20 passengers, giving it roughly 10 times the seating capacity of the two-seat Cybercab. Once passenger capacity becomes the main objective, maximizing interior volume becomes much more important than maintaining traditional vehicle proportions. Every inch occupied by a hood, engine compartment, or driver's cockpit is space that cannot be used by passengers. By treating the entire vehicle body as one unified architectural space, Tesla can dedicate much more of the vehicle's footprint to usable cabin volume. The patent drawings reinforce this concept. Tall sidewalls, a high roofline, and nearly vertical front and rear surfaces maximize interior room while keeping the external footprint relatively compact. The same basic principle can be seen in high-speed trains and modern metro systems, where efficiency is measured less by horsepower and more by. Another fascinating part of the design is its apparent inspiration from Art Deco transportation. Instead of using the sharp and aggressive geometry associated with the Cybertruck, the Robovan uses smooth curves and continuous horizontal lines. Rounded corners replace sharp edges, while the body appears to flow smoothly from the front to the rear. This influence appears far from accidental. During the 1930s and 1940s, streamlined locomotives, such as the Burlington Zephyr, and luxury intercity buses, used Art Deco-inspired styling to represent technological advancement. Their curved bodies reduced visual complexity while creating the impression of effortless movement. Tesla appears to be applying a similar philosophy to the autonomous transportation era. Rather than making the Robovan look intimidating or overly mechanical, its flowing shape communicates calmness, sophistication, and accessibility. Those characteristics could be particularly important for public transportation because passengers need to feel comfortable and trust a vehicle operating without a human driver. Perhaps one of the most unusual aspects of the Robovan is what Tesla has deliberately removed. There is no traditional grille because there is no combustion engine that requires airflow. There is no conventional hood because there is no front-mounted engine. There are also no obvious side mirrors, consistent with Tesla's long-term dependence on camera-based perception. Most importantly, there is no clear driver's compartment. That represents one of the biggest changes in automotive design since the automobile itself was invented. Traditional vehicles are designed around the driver's needs. Tesla's Robovan is designed around the needs of everyone except the driver because, ultimately, there is not supposed to be one. Another major feature of the Robovan is its enclosed wheel architecture. Unlike traditional buses and vans, where large wheels are clearly visible beneath the body, Tesla appears to position the wheels and suspension deeper underneath the vehicle and cover them with smooth body panels. The result is a silhouette that almost looks as though the vehicle is floating above the road. This is more than an artistic choice. Exposed wheels can create significant aerodynamic turbulence. Engineers estimate that the wheel area can account for roughly 20 to 30% of a vehicle's aerodynamic drag, depending on speed and overall body design. Tesla has consistently treated aerodynamic efficiency as one of its major advantages. The refreshed Model 3, for example, has a drag coefficient of approximately 0.219 CD, making it one of the most aerodynamic production sedans, while the Model S remains around 0.208 CD. Tesla has not yet released specific aerodynamic figures for the Robovan, but enclosing the wheels follows the same efficiency-focused engineering philosophy. Reducing aerodynamic drag can directly lower energy consumption, extend driving range, and reduce operating expenses. Those advantages become especially important for an autonomous vehicle expected to remain active for most of the day. Another visually striking element shown in the patent is the continuous glass canopy surrounding the upper section of the passenger cabin. Instead of separating the side windows with thick pillars and conventional frames, Tesla appears to wrap a dark glass band around much of the passenger compartment. The curved ends of the glass soften the proportions and make the vehicle appear visually smaller. From an architectural perspective, this creates the impression that the roof is floating above the main body. Similar techniques are often used in modern architecture to make large structures appear lighter, and Tesla seems to be applying the same concept to the Robovan. Even though the vehicle is significantly larger than a normal passenger car, its design avoids making it appear overly bulky or intimidating. Instead, it creates a feeling of openness and accessibility, which could be important for a vehicle designed to transport large numbers of passengers. The large panoramic windows also serve a practical purpose. Research into public transportation design has consistently shown that passengers tend to perceive vehicles with larger windows as more spacious, comfortable, and secure. Natural light can reduce feelings of confinement, while improved outward visibility can make longer journeys more pleasant. Tesla appears to be treating the Robovan not simply as a transportation machine, but as an environment where passengers could spend considerable amounts of time. The patent drawings also reveal several horizontal layered bands running along the sides of the vehicle. Tesla has not specified exactly what these elements will do, but the parallel lines could serve several functions. Visually, they break up what would otherwise be a huge uninterrupted body surface. Functionally, they could potentially incorporate full-width LED lighting, turn signals, autonomous communication indicators, or even aerodynamic elements. This would fit with Tesla's recent design direction. The Cybercab introduced continuous front and rear light bars instead of conventional headlights, while newer Tesla vehicles increasingly use lighting as part of their overall visual identity. As autonomous vehicles become more common, exterior lighting could eventually evolve beyond simple illumination and become a way of communicating vehicle status to pedestrians, cyclists, and other road users. The Robovan's horizontal design appears well suited to that kind of development. The overall proportions also reveal a strong focus on maximizing usable space. Unlike conventional passenger vehicles that sometimes sacrifice practicality for sporty styling, the Robovan appears designed to make use of almost every available cubic inch. The front and rear sections are nearly vertical, while the sidewalls extend close to the full height and width of the vehicle. This box-like structure allows Tesla to create a very spacious interior without dramatically increasing the vehicle's external dimensions. That philosophy is also visible in the interior concepts. Rather than using rows of tightly arranged seats like a traditional city bus, the Robovan features an open cabin with lounge-style seating, wide aisles, generous legroom, and large panoramic windows. The atmosphere looks more like an airport lounge or premium train carriage than conventional public transportation. Tesla also appears to be emphasizing flexibility rather than permanently fixed seating layouts. The large interior could potentially be configured for airport transfers, employee transportation, urban transit, autonomous ride-sharing, or premium mobility services depending on the operator's needs. Because there is no driver's cockpit consuming valuable floor space, a much larger portion of the cabin can be dedicated to passengers. The patent illustrations also appear to show that Tesla has considered cargo transportation in addition to passenger service. One concept includes a dedicated luggage area integrated into the lower rear section of the vehicle. Separating luggage from the passenger area could improve comfort while allowing the Robovan to serve several different purposes, including airport transportation, hotel shuttles, commercial logistics, and autonomous package delivery. That flexibility closely matches Elon Musk's earlier comments that the Robovan could transport both people and goods, making it useful for much more than traditional public transportation. Perhaps the most interesting aspect of the design is how intentionally different the Robovan is from the Cybertruck. Although both vehicles come from Tesla, they communicate completely different personalities. The Cybertruck emphasizes strength through stainless steel, sharp geometric surfaces, and aggressive industrial styling. It is designed to communicate toughness and durability. The Robovan takes the opposite approach. Soft curves replace sharp edges. Hidden wheels replace visible mechanical components. Continuous glass replaces segmented windows, while flowing body surfaces replace flat, exposed panels. The result could best be described as a retro-futuristic public transportation design that combines the elegance of Art Deco streamliners with the simplicity of modern consumer electronics. Rather than looking like industrial equipment, the Robovan resembles a welcoming public space on wheels. Ultimately, the newly granted design patent confirms that Tesla is protecting much more than an attractive exterior. It is protecting the visual identity of a potentially new category of transportation. The Cybercab is intended for individual autonomous ride-hailing trips. The Tesla Semi is focused on transforming freight transportation. The Robovan sits between those two products, offering high-capacity autonomous transportation for airports, factories, campuses, entertainment venues, city centers, and public transit systems. Its continued appearance within Elon Musk's Terafab vision, combined with Tesla's decision to legally protect its design, suggests that the project remains active. Tesla has not yet announced a specific production date, but the patent makes one thing clear. The company is already building the intellectual property foundation for what could become one of the most recognizable autonomous public transportation vehicles of the next decade. Thanks for watching. Make sure to hit the like button, subscribe to the channel, and turn on notifications so you don't miss our next breakdown. See you in the next video.